concepts we have that we are going to study. Then moving ahead for recursion, that is solving a problem by using recursive method, okay, which is something called calling itself. Then we are going to move ahead with the stacks and queues. We study stack and queue, and then binary trees. We'll move to the trees. Then we are by using the trees, we are going to study about sortings, which is about the merge sort, selection sort, bubble sort, and insertion sort. These are sorting techniques in which you can sort, for example, the numbers in ascending order or in descending order. So these four sorting techniques you are going to study. Then you have graphs, going to study how to represent a graph, okay, and you have different topics, I mean different things in the graph, that is graph traversal and searching in a graph. Okay, there are two methods, depth first search and breadth first search. Okay, so at the end will, if there is a time, we're going to have a revision of all these topics. So you have starting from the arrays till the graphs in this course to study. Now these are all the data structure items. Starting from the arrays, you have array, you have linked list, you have queue, you have stack, you have trees, and you have graph. So this is the main 6 topics you have to study in this course, M180. And again, you will be having one midterm and one TMA. Midterm will be in the 8th week and TMA submission will be 10th or 11th week. Okay, so you will get the dates once you'll receive your LMS and you receive your the TMA homework. Okay, so again the same fashion of the assignment grading, that is the midterm exam will be for 30 marks and the TMA homework will be for 20 marks and 50 marks for the final exam. Okay, this is about your the outline of your course, and this is what you are going to study in this course. So if you have any doubts, you want to ask anything about the course, you can ask now. Okay, we'll move ahead with our first class about the overview and the arrays in Java. In this meeting, we are just going to look about just going to look about the overview of the course, what you are going to study, and we start with the arrays. Okay, arrays I think you have already studied in Java in M105. Okay, we just have a look into the arrays, and then you have after that two-dimensional array. So if there is a time left in the class, we are going to continue with the two-dimensional array. If not, we will continue in the coming meeting. Now to start with an overview of this course, in this course you are going to study about the data structure. Now what is a data structure? It is nothing but a way of organized and manipulated data, or how you are going to organize the data which can be manipulated easily or which can be accessed easily. Okay, a general definition you can look into: a data structure is a scheme for organizing the data in a memory of a computer. So, or it may be referred the way data is organized and manipulated and seeks to find the way to make data access more efficient. This is the general definition for data structure. Okay, so here it is, what you are doing is arranging the data in the memory in such a way or in such a fashion that it is easy to access, and it can be easily accessed and manipulated. Okay. Some of the common data structures which are used by the programmers nowadays to organize the data is the list, arrays, stack, queues, trees and graph. Now all these you are going to study in the course. What are the lists, what are the arrays, what are the stacks, queues, trees and graphs. Okay. So these are the 6 main data structures which you are going to study in the graph. Computer programmers are going to decide which data structure to use for which data. So it depends on type of data, what type of data you have. Based on that you are going to decide which data structure to use. Okay, whether to use list or queue or tree or a graph. Okay, now here is some definitions for these data structure, algorithm and pseudocode. A data structure, as I told, refers to the way data is organized and manipulated and seeks to find a way to make access more efficient. Whereas an algorithm is a step-by-step procedure. Step-by-step procedure to perform any task, and which has some definite steps. Some definite steps. For example, 10 steps, 20 steps, 40 steps, 100 steps to solve any problem or to solve any task. And whereas a pseudocode, it refers to an informal language used to describe the algorithm. In algorithm, you are going to write the steps. Step number 1 is start. Step number 2, you write the second step. Step number 3, step number 4, it goes step by step. Whereas in pseudocode, you don't have to follow the steps. You just write in English how the problem can be solved. Go on writing that how the problem can be solved. By looking into the pseudocode, the programmer can easily write a program. Okay. So in pseudocode, programmer does not need to follow any strict syntax rules as the programmer will do in writing a program. For example, you are writing a program to solve any problem. In that case, by using Java, let's say by using Java language. In that case, you have to follow the syntax rules of Java to write the program. That you have to declare a class, you have to write a main method, you have to declare variables, and you have to do so and so and so to write the complete Java program. But in pseudocode, you don't worry about the rules. You just write a statements which will describe how to solve the problem. Okay. For example, let's say problem of finding numbers. Now, we are talking about the pseudocode. Pseudocode, for example, let's say that we have a problem of finding an odd number. Okay, let's say 25. We need to check whether it is an odd or even number. Now here, let's say if the number is divisible by 2, yeah, if the remainder is 0, then it is an even, or it is an odd, else it is an odd number. Okay. Now how do you explain this in English is when you write the pseudocode, you say input the number or get the number from the user, comma, divide the number by divide the number by 2 and check for remainder. If the remainder is 0, then the number is even. Otherwise, the number is odd. Now this is something called pseudocode. By reading this pseudocode, programmer can easily write a program, okay, in Java or in any language. This is called pseudocode. Now for the same pseudocode, if you are asked to write let's say an algorithm, for the same pseudocode, what is there? If you are asked to write the algorithm, okay, so what you will do, you write the steps. Step 1, start. Step 2, input number. Step 3, divide number by 2. Step number 4, check for remainder, and goes on. This is called an algorithm. Okay, so you got the difference between an algorithm and a pseudocode. Okay, moving ahead for linear and non-linear data structure. In data structure there are two types, linear and non-linear data structure. A linear data structure in which elements are adjacent to each other, follows one after the other. So when the element goes one after the other, we say that it is an linear data structure. For example, this is element number 1. It follows element number 2. It follows element number 3. So it goes adjacent to every other element. This is called linear data structure. Or if you see a queue in a supermarket checkpoint or checkout, you see one person follows the other. This is called a linear data structure. Whereas in non-linear data structure, each data element can connect to more than one adjacent element. Each data element can connect to more than one adjacent element. Here you see every element is connected to the next element, only one element. But in non-linear data structure, one element can connect to more than one element. And this can connect to two more elements. So this is something called tree in data structure. Okay. We'll see here the examples which are given here for linear data structures are array, linked list, stack and queues. And for non-linear data structure it is trees and graphs. Here's just a diagram for about the data structure and two types of data structure, linear and non-linear data structure. Under linear you find arrays and linked list, stack and queues, and non-linear trees and graphs. Okay. Here is an example of queue. A queue has two ends. One is beginning, the other is the end. So here it starts from this is the beginning, or you call as front end, and this is the back end. Okay, and queue is processed one after the other. The elements, these are the elements 1, 2, 3, 4, and they are adjacent to each other. Here is an example of a tree called binary tree, in which you can see the tree data structure in this diagram, and it is organized in ups and downs, and it is organized from top to the bottom. The topmost node of the tree, okay, is called it as a root. Okay, every element in the tree are called as nodes, and the topmost node is called it as a root, and the bottom nodes, these are called as leaf. Okay, and in this tree structure you can see one node has two adjacent elements. Okay, and this is a non-linear data structure. Now, when to choose which data structure to choose when you are writing a program, okay, or a programmer when need to be choose any data structure. Now, which one to choose based on what? Now, here choosing data structure by comparing the queue with the binary tree, you can see how the data structure how the structure of the data affects what can be done efficiently with the data. For example, if you have a, a queue, like for example queue in a printer to print the papers, or a queue in a supermarket, okay, so at this point we can use a queue data structure in the program. Here there is an example of printer. So the jobs will be printed in order in which they are received. Okay, the paper are coming to the printers one after the other, and they are printed one after the other. A binary tree is a good data structure to use for searching sorted data. Okay, for example, let's say the binary tree has, we write a binary tree for some numbers, sorted numbers. Okay, so it can be used to search the data. Okay, for example, we say here 10, 5, 4, 3, 2, 1, and this is 11, 12, 13, 14. Okay, now if I want to search 11, then we see 11 is greater than 10, will go on this side. If you want to search 5 or 4 or 3 or 2 or 1, then we see 10 is 5 is less than 10, will go on the other side by skipping one part completely. So choosing the binary tree is the best for searching the data. That's why the telephone dictionaries, they used the binary tree to sort the data so that it will be easy to search the data. The next, it talks about arrays and the list. Now arrays and the list, you can see the difference. In arrays is nothing but, before talking about arrays and the list and their difference, array is nothing but a set of elements, and the list is nothing but also a set of elements. The difference between arrays and the list is, if any element in the array is removed, then that space will be left as blank without filling it. But in the list, if any space is removed, then that will be filled by its next element. This is the difference between arrays and the list. Okay, so this is just an overview about the data structures. Now here we'll start with the arrays. Now array, what is an array? It is nothing but a collection of similar items having same type and same name. Array is nothing but a collection of similar items having same type and same name. For example, an array of 10 numbers. So all the numbers of same type and they are they have the same name. All the numbers will have the same name, but their difference is in position. Okay, for example, 10 numbers, let's say 10, 20, 30, 40, 50, 60. Let's say 6 numbers. We can put this in an array, in one array. For example, let's say numbers. Okay, now all these elements comes under the array number. The first element is 10, second 20, 30, 40, 50 and 60. So array is what? Is a collection of items or the elements of same type and it has same name. An array makes it easy to manipulate a millions of test scores as if it is one or two scores. Okay, because the numbers are arranged in sequence, we can manipulate millions of numbers, okay, by using an array. When dealing with an array, data is stored and retrieved by using an index, which refers to the element number or the position of the element or the number of the array in the data sequence. That means that data can be accessed in an array in any order. Okay, because you have the position number, you can just use the position number or the index number to access the data from the array. Let's take an example of 10 test scores. If you want to write a program in which you want to include 10 scores, okay, of type integers, then you declare 10 variables to store 10 scores of type integer. And this is not the proper way to declare it. By using an array, it is very easy to declare. Okay, how it is that we declare an array int test is equal to new int of 10. Now here test become an array which can hold 10 numbers of type integer. The single variable called test can hold 10 numbers of type integer. The items in the array are called as an elements. That is those numbers are called as elements. For example, let's say there are 6 numbers 10, 20, 30, 40, 50 and 60. And let's say this is an array called test. Okay, every item is called it as an element. Okay, element of an array, and this is accessed by the index or by its position. The index starts from 0, 1, 2, 3, 4, 5. This is the 0th position, the first position, second position, third, fourth and in the 5th position. So with the help of index or subscript, also call it as an subscript. This is called the index or the subscript. So with the help of index or the subscript, we can access the element of the array. Okay, for example, if you want the first element of the array, you can write test of 0. This will give you 10. That is the first element of the array. If you write test of 2, this will give you how much? Yeah, if you write test of 2, how much it will give you? Yes, it will give you 30. Okay, so like this, if it is your test of 4, it will give you 50. So with the help of index, we can access the elements of the array. So the index starts from 0 to the number of arrays minus 1. Okay, for example, that there are 10 elements, so index starts from 0 to 5. Okay, here is a graphical representation. The first row represent the index, the second row represent the element or the values of an array. So at the zeroth position or the first position, the value is 2. At the second position, the value is 1. At the third position, the value is 11. Okay, for example, if you name this as test of array, then you can access by the help of text of 0 as 2, test of 3 as minus 9, test of 6 will give you 11, okay, and so on. However you want, you can access those elements. Now how to declare an array? What is the general syntax to declare an array is by using the name of the array and specifying the index or the I'm sorry, this is not the declaration. Yeah, here is an declaration of the array. So how to declare an array is by specifying the name of the array along with the type, okay, and by using the square brackets. Okay, so the type of the array will be specified, the name of the array and the brackets will be used to declare an array variable in Java. Now once you declare this in the memory, there will be a null object with the name of the array. There will be a null object with the name of the array. Then to this object you need to allocate the memory. So how to allocate a memory? By using a keyword called new, which is something like this. Num is equal to new integer of how many elements? That is 4. Okay, so it is two steps. Now the first step is int num, and the second step is num is equal to new int of the size of the array. Now to this numbers, the size an array of 4 elements is assigned. Okay, so now this object is referring to the first element of the array, and by default, since this array is of type integer, it will have the value 0 by default. It has a value 0 by default. Okay, so first thing is declaration, which is done something like this, okay, which you have seen over here. It will just declare an object. The second thing is an allocation, which will allocate a space for the array by using a new operator, which is something like this. And the third, and after you do this one, in the memory there will be 4 spaces allocated to store the integer values in sequence, one after the other, and the default value will be 0 because your array is of type integer. Okay, and finally initialization, and we can initialize the array in different ways. Okay, initialize, it means assigning the values to the array. Okay, in different ways we can initialize the array. For example, we can use a for loop, or we can use a direct initialization. Now, for example, if you use a for loop to initialize array, you start a loop from starting I from 0 till less than 4, because you have 4 elements, 0, 1, 2 and 3, which is up to less than 4. Then I plus plus, increment the I, and number of I is equal to I into 2. So your array will have these numbers 0, 2, 4 and 6. 0, 2, 4 and 6, because the first you start the loop, I will be 0, 0 into 2 will be 0, so number of 0 is 0. Okay, when I is 0, the number of 0 will be I into 2, that is 0 into 2 will be 0. When I is 1, after that I will become 1, I1, number of 1 is 1 into 2, 2. So it will be 0, 2. When I is equal to 2, then number of 2 is equal to 2 into 2, 4. Then when I is equal to 3, it will be 3 into 2, 6. When I becomes 4, 4 less than 4 false, it will come out of the loop. So by using this for loop, we can initialize the array to its elements. Now here to declare and instantiate an array, say let's say ABC of 500 integer values, we write int of ABC is equal to new int of 500. Okay, all the values in this ABC will be given initialized with a 0 by default, because ABC is of type integer. Now array objects or the arrays must be instantiated before being used. Before you use an array, it should be instantiated or should be initialized. Okay. There are several array variables can be declared in a single statement. For example, which is something like this: int of a, b, c, comma x, y, z. Like this, you can have any number of array variables can be declared while declaring. It is in declaration, so it can be declared. Okay, then you have to initialize them, or you have to allocate the memory one by one. Okay, you can declare more than one array element or array variables, but when you allocate the memory and when you initialize them, you initialize and allocate the memory one by one. You cannot do it as once. Now, because arrays are object, two variables can refer to the same array as indicated in this example. Okay, here we are creating two arrays. One array called ABC, the other array called XYZ. Now we in the second statement we instantiated the array with 5 integers. ABC is equal to new int of 5. So you see in the memory what happened. ABC will be created. Okay, this is an array which will refer to the 5 elements. Let's say 1, 2, 3, 4 and 5. Okay, by default the values for the elements will be 0 because ABC is of type integer. Then in the third statement we made XYZ to refer to ABC. XYZ is created when you do this XYZ. Then it is also referring now in the third statement to the ABC. Now when you change XYZ of 3, that is 0, 1, 2, 3, This is 4. So xyz of 3 is equal to 100. Then here it will be 100. Now if you try to print ABC of 3, now what is ABC of 3? It is also 100. Why? Because the both XYZ and ABC are referring to the same array. Okay, so that's what it says, because arrays or object, two variables can refer to the same array, which is indicated in this code. So here it is a graphical diagram for that case, for this case. Now we can also initialize the array at the time of declaration. At the time of declaration, if you know the values of the array, we can directly initialize them with this statement. Int of ABC is equal to, with a flower bracket, 1, 2, 3, 4, 5. So what happens here? In the memory, there will be 5 elements. 1, 2, 3, 4, 5, in which values will be stored as 1, 2, 3, 4 and 5. Their index will be 0, 1, 2, 3, 4. Now here then are arrays of double, character, boolean, string and student. So this means that you can declare an array of any type. If you want to declare an array of double, you can declare an array of characters, you can declare an array of booleans, you can declare an array of strings, you can declare an array of any object. Okay, for example, class, student, you can declare an array of students. Okay, you can declare an array of strings, any data type or any reference data type, you can declare an array of such data types. Okay, so here it is, there are some double, some characters, some boolean, string, student. Okay, different data types and different classes of the array of different types is given over here. Now simple array manipulations. You can change or manipulate the array elements by using the index. Okay. So anything you want to do, any manipulation you want to do in an array, you can do it by the index. Okay. For example, let's say there is an array of called ABC. Okay. With 5 elements, and you want to assign the elements, first 5 elements, you can assign it by using ABC of 0, ABC of 1, ABC of 2, or you can say ABC of I, where I is equal to 3, and ABC of I plus 1, so it will be 4, ABC of 4. Okay, so like this you can manipulate an array by using the index of the array. Okay, so here if it is an ABC array with 5 elements, okay, the first ABC of 0, this is ABC of 0, 1, 2, 3 and 4. ABC of 0 is 78, ABC of 1 66, ABC of 2, ABC of 0 plus ABC of 1, that is 78 plus 66. So how much it will be? 14 on 144. And then ABC of I, what is I? I is declared as 3. So ABC of 3 is 82, and ABC of I plus 1. So what is I? It is 3, 3 plus 1, it is 4. So ABC of 4 is 94. Okay, so this is an ABC array to which we did assign the values by using the index. Now while manipulating the array, okay, the JVM checked the values of the subscript before using them and throws an array index out of bound exception if they are out of bounds. Out of bounds, it means, for example, you have an array of 5 elements. You declare an int let's say you declare an array of integer int abc is equal to new int of 5. Okay, so 5 elements, an array of 5 elements called abc you declared. Okay, so what happened in the memory? You got an array of 5 elements 1 2 3 4 and 5. So index from 0 1 2 3 and 4. This is an array abc. Okay, now if you want to let's say the initial values are 0 1 2 let's say 10 20 30 40 and 50. Okay, if you want to access the first element, if you want to access the first element abc of 0 will give you 10. Now if I say abc of minus 1, but there is no index minus 1 over here, so in this case the JVM or the Java will throw an exception or will give an error called array index out of bound exception. Or for example, if I say abc of 5, there is no fifth index over here. In this case, it will throw array index out of bound exception. So it means that if you are using the index which is not there for an array, then the Java or the program will throw an exception called array index out of bound exception. So you need to be very careful when giving the index. We can also interchange the element of the array by taking the element into an temporary array. Okay, so it's very simple. Let's say you have two elements 82 and 95, that is abc of 3 and abc of 4, where abc is an array. Now let's say you want to change the you want to interchange the values. You need to assign 95 to abc and 82 to abc of 4. Okay, you want to interchange the values, also called swapping the adjacent elements. So how you can do? First you take the index of the first, that is I is equal to 3, and you assign that into a temporary variable. So temp is equal to abc of I. So what is I? I is 3. So you take the value of abc of I, that is abc of 3, that is 82, into temporary variable. So your temporary will have 82. Then you make abc of I is equal to abc of I plus 1. What is I? I is 3. So abc of 3 is equal to abc of 3 plus 1, which is 4. abc of 4. What is abc of 4? 95. So now you are assigning 95 to abc of 3. So abc of 3 now will have 95. Then after that, what you do? abc of I plus 1 is equal to temp. Now what is the value of temp? It is 82. 82 will be for abc of, what is I? 3. 3 plus 1, 4. So abc of 4 will have 82. So here you will get 82. So you swap the elements or the values of the adjacent elements. We can also know the length of the array, that is what is the size of the array, by using a variable called length. Okay, for example, let's say you have an array of ABC. So you want to know the length of the ABC, you can use ABC dot length to know the length of the ABC. Now what is the length of the ABC? It is the size of the array. For example, you declare ABC of 4 will be, yeah, ABC of 4 will be uh, 82.